'cause after all, the city never sleeps at night. It is time to begin. Yes, see how I did that? Picked up right where we left off with good old Imagine Dragons. We are differentiating like it's 1999. Simple rules for differentiation. And we just got a couple more examples here. Let's get to it, shall we? Find the gradient function of y equals x squared minus 4 over x, and hence find the gradient of the tangent to the function at the point where x equals 2. Okay, so we have y equals x squared minus 4 over x, and I do not yet know how to take the derivative with the variable in the denominator. So I'm going to rewrite my function in a form where I do know how to take the derivative, and that is going to be 4x to the negative 1 power. So then y prime is equal to, let's see, 2 times 1, there's really a 1 in front of here, is 2, x to the 2 minus 1, so that's x to the first power. Negative 1 times negative 4 is a positive 4, x. Negative 1 minus 1 is negative 2. And there we have our derivative. Now I am going to rewrite this, and this is a good example of when you probably don't want to deal with negative exponents. And so this will be 4 over x squared. Okay, so we have found the gradient function, the slope function, because we can use this to find the slope of the tangent to this curve at any point that's in the domain of the function, any value of x. Okay, so they're asking me to find the gradient of the tangent to the function at the point where x equals 2. So they're really just asking me to find y prime of 2. Yes? Well, y prime is equal to 2x plus 4 over x squared. So y prime of 2 is going to be equal to 2 multiplied by 2. Okay, I just replaced this x right here with the 2 plus 4 over 2 squared. Yes? Replacing this x with 2. So this becomes 4 plus 4 over 2 squared is 4 over 4, which is 4 plus 1, which is indeed 5. Okay, so let's just see what that looks like on the calculator. I have that all ready to go. That's not it. This is it. X squared minus 4 over x, and slope of the tangent line, I've already got it all set. I believe we were asked to find what's the slope at 2. I'm going to let x be equal to 2. Okay, so x equals 2, and it tells me the slope of the tangent line is indeed 5. So we did it graphically here, and well, we're using technology and using calculus right here. Awesome. Okay. Last two examples, and we're out of here. Find the gradient function for each of the following. Okay, f of x equals 3 root x plus 2 over x. I do not know how to take the derivative of a square root. However, I do know how to take the derivative of a variable with an exponent. And remember, you can write the square root of x as x to the 1/2 power. And like we did before, I'm going to rewrite 2 over x as 2x to the negative 1. So the derivative is equal to, this is my n, 1/2 times 3 is 3/2. X, 1/2 minus 1 is negative 1/2. Negative 1 times 2 is a negative 2. X, negative 1 minus 1 is negative 2. And I am going to clean that up. I don't like negative exponents, especially when they're fractions. So that's going to be 3 over 2x to the 1/2 minus 2 over x squared, which is equal to, I'm going to rewrite this as a radical, 3 over 2 root x minus 2 over x squared. And I know you're saying, do I have to do all this simplification? If you're asked to find the derivative, then this is a perfectly good answer, if that's all you're asked. But let's say you had to find the slope of the tangent to the curve at like x equals, I don't know, 9. Well, if you're in this form, you're probably not going to be able to do it in your head. But if you get to this form, this is a bit easier, I think. And so our last example, find the derivative of this, and I asked this question: what is the gradient of g of x at x equal to 1 and at x equal to 4? Just two different gradients. So I'm going to have to rewrite this one in order to do the problem. So I'm going to rewrite it as g of x is equal to x squared minus, now that's 4 over x to the 1/2. So if I move the x up into the denominator, in the numerator from the denominator, that's going to be 4x to the negative 1/2. Okay, so the derivative of g of x is going to be equal to 2x. 2 times 1 is 2. 2 minus 1 is 1. A negative 1/2 times a negative 4 is a negative positive 2x, careful, negative 1/2 minus 1 is actually negative 3/2. Okay, perfectly a good answer to find the derivative. But what if I don't have a calculator and I have to do all this? Well, I need to know what this means, this x to the negative 3/2. So I am going to rewrite this as 2x plus 2 over x to the 3/2, first of all, which is equal to, now I'm going to write it as a radical, 2x plus 2 over the square root of x cubed. Okay, that's what 3/2 means. Now the cubed can go outside the square root, or you can cube the x first, then take the square root. I like it better like this. So g prime of 1, to find the gradient, is equal to 2 times 1 plus 2 over the square root of 1 cubed. All I did is I took my gradient function, the derivative, and I replaced x with 1. So this becomes 2 plus square root of 1 is 1, 1 cubed is 1, so 2 plus 2 over 1, or 2 plus 2, which is 4. And then g prime of 4, is that it? Yeah, g prime of 4 is equal to 2 times 4 plus 2 over the square root of 4 cubed. Okay, replacing x with 4. So that is going to equal 8. 2 times 4 is 8, plus 2 over, let's see, the square root of 4 is 2, so 2 over 2 cubed. So that's going to be 8 plus 2 over 8, which is equal to 8 plus 1/4, or 8 1/4, or 8.25. Okay, so let's check that out on the calculator. For 1, we had a slope of 4. At x equals 1, we had a slope of 4. And at x equal to 4, we had a slope of 8 1/4. So let's see how that rolls. There we go. We'll start with 1, just to see if we did okay. And the slope is indeed 4, right there. Hooray! And then the other one was 4. And we're expecting 8.25, which we got. Okay, the slope of this tangent line when x is equal to 4. That's all I got. Hope you enjoyed it. We will see you next time. I can't wait!